Hey Adam,
Hey,
how
how
are you
you
doing,
doing?
buddy?
Good to see you.
Good to see you. Thank
Yeah.
you. Could you take a picture of me, please?
Yeah, of course.
Oh, thank you. Thank you.
Wait, what is that?
What is it, Adam?
There's a box around your face.
That's a face detection feature. It's used to detect my face and blur the background behind me.
Oh, really? Can we apply it to Python or different language packages?
Yes, we can. There is a package for it. It's called OpenCV.
OpenCV, I've heard about that. It can like process images,
Yeah,
videos, identify
exactly.
objects. It's a
It does.
really useful resource I wish more students knew about.
It is. It is. You know what? How about we present it to the class at the Computational Tools project?
Actually,
Yep.
let's do it.
Let's do it.
What is OpenCV? OpenCV is a free open source library designed to provide a wide range of tools and functions for tasks related to computer vision, imaging processing, and machine learning, making it a valuable resource for researchers and developers as it allows users to manipulate, analyze, and understand visual data. In order to detect faces in the image, we need a model that will perform image analysis for us. Luckily, OpenCV is equipped with a pre-trained HAR cascade classifier algorithm. The HAR cascade is an object detection algorithm, and it has been trained on a large volume of images for detection of certain features like faces. And the algorithm runs in real time and is used in this program. Next, we need to load the image we want to detect faces in. Line 3 of the code here reads the image using the CV2IM read. But before that, we actually need to upload the image. 3 lines of code will be used to represent the image right here, right here, right here. In order to simplify the facial detection process, it is necessary to convert the original color image to grayscale. Grayscale simplifies the HAR classification algorithm and reduces the computational complexity. With detect multi-scale, it intakes the grayscale image and accepts the arguments for scale factor, min neighbor, and min size. With scale factor right here, it compensates for different sized faces and images. With min neighbor, it controls the accuracy of face detection by considering the number of overlapping rectangles required for a valid detection. With min size, it determines the smallest size of a detected face. Lastly, the code here lists all the detected faces, gathers the coordinates, the dimensions, and finally a green rectangle should place over the image. Et voila, there we have it. Now Patrick will expand more on the dynamic image analysis.
As Adam has described, we can use OpenCV to detect faces in a static image. Now I'm going to modify the code that he presented on and show how we can apply this to a live video feed. First, I'm going to import the CV2 module in line 3 of the code. Next, I'm going to use the cascade classifier method. This introduces the hard cascade algorithm, which Adam used in the static example to detect faces. We can also use this to detect faces in a live video feed. Next, I use the video capture method to give OpenCV access to my webcam. The webcam will be the source of the live video feed for this example. Now we move into a while loop. In this while loop, I introduce a variable called frame on line 10, which uses the .read method. .read allows OpenCV to interpret the images that we're capturing in real time. In line 12, we convert the feed to grayscale. We do this for the same reason as before, to reduce computational complexity and make algorithmic sorting easier. Now we can use the detect multiscale feature with the same parameters as before. This will allow the cascade classifier algorithm to detect faces in the web feed in real time. In line 16, we use the same for loop that we used in the static example. This time, we will apply the green rectangle to my face in real time. Now, we can run the code and see what happens. As expected, when we run the code, we obtain a live feed of my laptop's webcam with my face detected in real time. This demonstrates the power of OpenCV. We have shown that we can detect faces in both static images and live video feeds. This brings us to the conclusion of Model 1, facial detection. Next, Aslam will introduce and explain Model 2, which involves using OpenCV for text detection.
This Python code is a text detection script that uses the pre-trained East text detector model. It takes an input image and returns a bounding box around each detected text region. The code uses OpenCV to read the input image, resize it, and convert it to a blob. It then uses OpenCV's DNN module to load the pre-trained East text detector module and perform a forward pass on the blob. Pre-trained East text detector model is a deep learning model that has been trained to detect text and images. The model outputs 2 layers, one for the probability of each pixel being text and one for the bounding box coordinates of each text region. Overall, the code works as follows: 1. Read the input image. 2. Resize and convert the image to a blob. 3. Load the pre-trained East text detector model. 4. Perform a forward pass on the blob to obtain the probability and bounding box layers. 5. Iterate over the bounding box layer and draw a bounding box around each detected text region. Using an example image of LeBron James, I'm going to see if it can identify the text in the image. As you can see here, it did a great job.
Thank you, Aslam, for explaining to us the coding part. Well, let's go through some technologies where facial recognition is being used. I mean, it's around us everywhere, right? In our phone, we want to unlock it. When you go to the airport and the security wants to check your identity, when you take some photos or videos, everywhere. However, one of the latest technologies where face recognition had been used happened to be by Google. They have announced a couple of weeks ago a feature in their new phone. Do you have that problem when you want to take a group photo, but in the first picture, that person wasn't smiling? The second photo, that guy wasn't looking at the camera, and so on. We have these endless problems. Google solved it with a very intelligent solution. Let's watch.
Wow.
I mean, it's really incredible sometimes how fast the world is evolving. Well, thank you so much, guys, for listening. It was me, Osama, Adam, Patrick, and Aslam. I hope you guys enjoyed the presentation and good luck.